Hello, everyone, and welcome to a drone mapping, advanced drone mapping webinar from Drone Launch Academy. Thanks for being here. My name is David Young. I'm the founder of Drone Launch Academy, and I have with me Mr. Rut Patel. Everybody say hello to Rut.
Hello, everyone.
All right. I see you guys got a lot of folks already here in the chat. Sorry, we're 2 minutes late getting on. Just trying to get my iPad hooked up, but I finally got it. So we can show you some things and do some teaching here this morning. All right. I see everybody from Florida. Got some newbies from California. A lot of California, upstate New York. You guys are always good about throwing where you're from in here. Can you guys hear me? You guys got audio? Let me know in the chat if you can hear me and Jordan. I can, or me and Rut. I can hear him. I want to make sure y'all can hear us. All right. Well, let's start off today. I'm curious. I want to know from you all's perspective, where are you at right now in the world of drones? Are you brand new to drones? Do you have a Part 107? Have you ever done mapping before? Are you in a job that requires you to do like geospatial data? Maybe you're using some drones. Let us know in the comments so I can know how to best talk about this. It's kind of, I'll say formal, informal setup here. I've got some slides that I can go through. Rut has a project that he's going to walk us through, and we'll introduce more details about ourselves in a minute. But Rut, on a day-to-day basis, does all the aerial data capture, intelligence analysis for a survey firm in Central Florida. I am David Young, founder of Drone Launch Academy. We've put together a bunch of different courses on drones and geospatial data and how to use it in professional settings. I've worked with drone manufacturers to test out their mapping equipment and workflows. So I'm in this world a lot, but I like bringing folks on like Rut, who are doing this every single day in the field so that he can bring his more tangible expertise to us. All right, let me look through some of these comments here. So we got a lot of 107, got years of experience, haven't done much mapping, studying for 107. So got some 107s, no mapping, working on 107. Okay, we got a few more specialized folks here. Got my 107. Done relative accuracy mapping for years. Looking to do some advanced. Okay, cool. All right. Oh, yep. So we have some kind of have a mixture of folks in here. All right. So today we're not going to try to make this all over your head. You might have heard some terms that we're going to use in here before. I'll try to keep it fairly simple, but just know what we're going to be talking about is some more of what an advanced mapping workflow looks like. So that's when you're getting into absolute. I view that as when you move from I can create a map to I can do something with what we call absolute accuracy, being able to prove real world accuracy, pin some type of map or geospatial model onto a specific point in the earth. So that way, when you are working with other professionals in the field, we get surveyors or engineers, they can take their data and lay it over the top and everything lines up. Or you can give them a report and they have validation that they know that this is extremely accurate, whether you're doing like a topographic survey or some other type of product, which we'll talk about, okay? Yes. Let me pull up. I got some slides. We're not going to do death by slides. I'm going to go back and forth between showing some slides. I like it because I can, write and draw on my slides to teach you guys some stuff. And then we'll do some screen sharing. Rut's going to show a project that he's done. So that's what we're going to do today. So I'm going to pop up my slides here so we can get some intro stuff going. Hopefully you guys can all see this. All right. So we're going to level up your drone skills today. We're going to teach you how to create high value maps and models. All right. So if you don't know anything about me, my name is David Young. Again, I'm founder, CEO of Drone Launch Academy. Had this company for over 10 years. I started off as a regular pilot, went and did accounting stuff for a while, came back to the drone world about 10 years ago. But we've trained, I think at this point, didn't update this slide, but probably over 60,000 people in commercial drone operations, everything from Part 107 to basic mapping, all the way up to mapping good enough to being used on for civil engineering and surveying. All right, so I got my advanced ground instructor certificate. Just as a credibility booster, I've worked with, again, some of the biggest companies in the mapping space. So if you're familiar with Wingtra, they make a really nice survey and mapping drone. They've let me test out their equipment in the past, give them some feedback on some of their survey workflows that they tried to do with all the different GCPs and integrating that into one software. So I was able to test that out for them. And then their CEO, Max, was nice enough to call me, I think maybe a little undeserved, but a top voice in the drone mapping space. So I thought that was nice. And the people he put me there with were much more qualified than me. So I'm not saying that to boost myself too much, but just at least I know a little bit of what I'm doing here. But I'm going to rely more on Rut for again, he's day-to-day, practical, knows everything that's going on kind of guy. All right. A little bit about Drone Launch Academy before I introduce Rut. So if you're not familiar with Drone Launch Academy, we are a drone education company. So partner with people like Rut and other instructors to do podcasts, to do webinars like this. We have some courses and certifications that people can do. And the whole goal is to help people understand how to use drones in a commercial setting that can either help them have their own business, advance their career, or if they're in a job or if it's an enterprise, utilizing their people to be more efficient, safer. Anytime you can send a drone to do a job that a person on foot or in a harness scaling up a building used to do, things become much safer and you can actually get it done a lot quicker. So it's about increasing efficiency, safety, all that stuff. So these are just some things where people have shouted us out on LinkedIn. Big geospatial companies, MLID, they make these receivers, Wingtra, Duncan Parnell, they sell survey equipment, Spexy. So about Rut. Rut, do you want to introduce yourself a bit?
Sure. Hello, everyone. My name is Rut Patel, and I'm currently working with a survey firm, 30 South, and we recently starting a new company called 30 South Geospatial that's designed to create solutions for surveyors, mapping solutions for surveyors. I've been doing drone stuff for about 12 years, all started in India. But when I moved here in 2015, I continued my work here. Had many experience in doing basically all kind of drone work, started with utilities, inspection, mapping, stuff like that. Started with the roof inspection, then moved on to cell tower, solar, utility inspection, went across all over the America to do all kind of work. So very happy to be here. Then I met David, and I've been working with him for at least 5 years on these kind of webinar we've been doing for almost 5 years, David, right?
Yeah.
Yep.
I would say
and I'm happy
right.
to share my knowledge.
Awesome. Cool. Well, yeah, Rut is always on the cutting edge. He's done so much stuff in drones, and it's awesome that he works with surveyors, engineers, literally every day. He was hired by a survey company to say, hey, come in, help us use drones for the stuff we used to do by hand. And so he's been working with them over the last year or so to set up a complete drone program for them. All right, so what are we covering today? We're going to talk real quickly about, since a lot of you seem a little bit newer to the drone world, and even if you're not, I think it's good to talk about sort of the shift I've seen in the last 2 years in the worlds of drone and drone mapping. I feel like the opportunities used to be more on the artistic side, I'll call it. So video editing, real estate media, sort of the things you might be familiar with seeing in everyday life. I might call those more like a business to consumer or more public facing things that are easy to share and people like watching them. I'm not saying there's no opportunity there, but that used to be what people think about. But as drones have progressed, I've seen a huge shift over the last probably 3 years, and I've got some data to back this up, of enterprise adoption of drones in the world of engineering, construction, surveying, inspections, transportation, and infrastructure, oil and gas, anything using drones and data has sped up very quickly over the last 3 years. It used to be where you could be a drone service business, and when you went out to go talk to someone and you wanted to convince you to say, hey, I can create an orthomosaic for you, or I can create a mapping product for you. You had a really steep hill to climb because they're like, what in the world are you talking about? Like all of a sudden they didn't really understand. They didn't know. It was kind of fuzzy. And then if you talk to big companies, they're like, I don't know if I want to hire, like, this is the way we've always been doing it, right? Any big organizations, there's gonna be a big reluctance to change. And I feel like that's finally starting to shift. And we've seen a lot of data that shows big companies are finally adopting things. It's becoming more of a required deliverable in a lot of construction projects to have drone updates or 3D models or drone maps, which are called like orthomosaic images. And so that's been a big push, and that's fueled by a few things that we're going to talk about. So I'm gonna show you what those are, so you can just have some data points for yourself. I also have this research report that I can send out afterwards. So what I was going to show you, actually, let me see if I can get this up here. I spent a lot of time researching this, and I wanted to make sure that you guys. Oh wait, where did it go? Maybe I'll find it in a second. I put together this like 16-page report on exactly all the research that I had done. Oh, here it is. I'm going to open it up for you. I want you guys to see it. I will send this out to whoever registered for the webinar, because I think it'll be helpful for you. It's going to cover many of the things that I'm going to show you today. All right. So advanced drone mapping. It's talking about market data. It's talking about job opportunities and how much they pay. And these are all backed up by like real verified sources, talking about premiums. We'll get into this stuff. What you can expect salary-wise if you want a job by income level, different skill gap, why now, drone mapping rates, what you can expect to make on different types of jobs, different paths for getting started if you want to do the drone business route, what it looks like, some real world case scenarios in case you ever needed to present this to someone else, what's driving it all this stuff, and then all the references, everything it's backed up with, every link and research report and references are right there. So I'll give that to you guys when we are all done here, if you want it. If you guys want this report, let me know if you do, and I can try to send it out. If you guys don't care, I won't. Let me know there. Let me know in the chat. Okay. So that's what we're going to be covering today. A little bit of background, and then we're going to walk through what are the steps if you're going to go get an advanced drone mapping deliverable. What does that take? What are the steps involved in that? What does that look like? I'm going to drill into a few specific pieces that you might need to like focus in on. And then I'm going to turn it over to Rut. We're going to go back and forth throughout the presentation. I'll turn it over to Rut to walk through his actual real life project example of what he's done. And then we'll talk a little bit about, if you really want to dive in and go deep with this, we have some courses and certifications that you can take if you're looking to get into this for like a full-time job, or if you're looking to take your business in this direction. Okay. That's what we're talking about. Sound good? Give me like a cool or a thumbs up in the chat. Okay. Seems like people want the report. Okay. So I will send that out afterwards to everyone who registered for the training. All right. So first, I always like to start with, I know you guys want to learn about mapping, and we will. We're going to cover all that. But it never sticks unless you're like, why do I care about it? Why should I care about it? If I show up to a training and they're teaching me something, this is like anything in school. If I can't think of how am I going to apply this later in my life, or how is this going to benefit me? Why should I care? It just goes in one ear and out the other. So this is me trying to convince you, hey, this is what I'm seeing. This is why I think you should care. Again, if you care about drones and this world, here are some things, some stats, some research as to why things happening now are pretty wild. Okay. So again, this is all backed up by actual links, and they'll be in that report. So global drone services market. This is not selling drone hardware. This is not any of the other things related to drone. This is people actually going out there with drones, providing a task, either on the data analysis side, the flying, something like that. It is blowing up. We're going to go from 32 billion. Oh, come on. Where's my pen? My pen dead. We're going to go from 32 billion. See if it reconnects here. Hey, 32 billion to 261 billion by 2034. So we are still on the tail end of it. That looks like this, and we are here. Okay. Drone data services also going to blow up. So that is the data that you're collecting from your drone, the stuff that Rut does. How is that going to progress in the next 10 years? Again, we're doing one of these numbers. Construction is a really good use case and primary example. It's going to increase. Drone analytics going to be huge. Photogrammetry for drones. So photogrammetry is the process of what we're talking about today. It's growing at 15% compounded. That's the C, compounded every single year. All right, so this is where I got those sources from. So market, big time, expanding. What they say is a rising tide lifts all boats. You want to be in an industry that is growing, because as you get in, the market gets bigger and bigger every year. And even just to give you another example, we have another side of our business that only focuses on high school curriculum. And what we've seen over there in terms of just high schools realizing, and the education market realizing, hey, this is a job of the future. We need to be training our students on this now. The number of schools demanding high school curriculum for drones and Part 107 certification and some of this other, they're actually interested in this mapping stuff too. I've seen that grow year after year. We've been doing that for about 3 years, and it continues to get bigger and bigger. Bigger school districts are wanting it. So every little data point I see, even from conversations I have with individual people in the market, and I'll share some of those in a moment, they're saying, I'll just share one with you. A friend of mine started a drone service business. He's had it on the side. He worked for a very large utility company as a part of specifically their drone program. And his side business doubled in revenue every year from 2023 to 2026. And it got so large that he just had to quit his full-time job to dive into this. I mean, Rut's been doing this too. Now, again, you're going to see that it's not just anybody with a Part 107 can do this, but if you have the right skills and you focus on the right areas and you really dedicate yourself to this and learning it, the upside is there. All right. So this was pulled as a survey from actual job postings that are out there. Right. So drone mapping specialist, drone surveyor, photogrammetry technician, reality capture technician, drone construction pilot, utilities and energy inspector, remote sensing analyst, GIS analyst. These are all above the national average in salaries. And you can see in the breakout, I don't know if I gave a breakout of the years. Yeah, in my other report that I'll send you, it shows what you can expect by year. But typically, if you have 5 years in this industry and you know what you're doing, you're looking at doing this for a job. All of the jobs are 6-figure plus paying jobs right now for full-time work. And I can verify this. There's a guy that used to work for me. He left my company and went and took a full-time job as a drone pilot doing geospatial work like this in a large organization. And he gets paid, I think last time I talked to him, it was like $120K per year. And they give him nice benefits and all this stuff. So, but it's only for people who know what they're doing. And I'll talk about this. So general drone pilot, if you look at those job postings, those are around 50 to 75K a year. If you have someone with mapping and surveying knowledge, geospatial experience, those jobs are typically 80 to 100K plus, right? Yeah, and this is if you have 5 years and go to 130K. I have a friend, again, I know people who have less than 5 years who are still making above 6 figures, right? And it's not the ability to fly a drone, right? We're going to see anybody can really fly a drone. 107s are not that special anymore, having a Part 107 license. Having the additional knowledge before and after is what sets you apart and what will allow you to get paid like this. Just some examples. So these are pulled off of some other industry stats. So they this financial models lab. They calculated average drone mapping project was 3,300. They had an average drone inspection job at 1,440. Aerial photography job was averaging $240. So if you get into mapping and inspections, it's literally 13x the revenue that you would get otherwise. Okay. So if you're looking to start this I'm talking about jobs. Now, if you're looking to start this as a business, a lot of people, so I told you about my one friend who had a business, and I know other people who take this route. You can start lean, right? You can start with a prosumer drone. So you can find like a used Mavic Air 2, or if you really wanted to get a nice one, maybe like there's a lot of like Mavic 3 Enterprise drones that are on the market. Those are several thousand, but you can get started something with something as an Air 2S, all right? And you can take on those, several $100 to $3,000 mapping jobs with that, right? Another path, and this is something Rut has done, you can rent equipment as needed. So let's say you get a bigger job and they're like, oh no, you need a more sophisticated drone and you need some better software or whatever. You can always rent that stuff. Rent it for that job, build it into your pricing, and then when you're done, you can give it back until you have a consistent flow. And Rut, would you say this is consistent with your experience being able to get like...
I agree. I mean, Don't let the equipment stop you, not having the equipment stop you from getting that work, There's plenty of resources available right now where you can rent it and perform the work. And then, just basically at that you're saying, but yeah, don't let that...
But I mean, even these level of jobs, like you started off in this, sort of the hundreds of dollars, and then we're able to move to the thousands of dollars, now up into the kind of 5 to 10K job range.
Yeah, that's minimum on each job, yes.
And again, that same financial models lab, they did a thing that said, hey, if you went crazy and you invested all in, you got a really, nice gear year one, which I don't necessarily recommend. It says year one, you would operate at a loss if you bought all that stuff, getting your, starting from total scratch. But then according to their calculations, they said year two, you'd be net profit of almost 300,000. I'm not going to go claim that that's what you're going to do, but that was their analysis. I do know that that
It's
being,
possible.
yeah, it is.
Easily, yeah.
All right. So real quick, 5 different tailwinds. Okay. Tailwinds are like things helping push this forward. So I'm just going to go quickly through these. So executive order signing, unleashing American drone dominance. Okay. That, I don't know, this my pencil thing is jacked up. I might not write on it as much. So beyond visual line of sight rules, a lot of people view that as potential threat to the drone operators. And I would say it is a threat to people who all they know how to do is fly. It's going to move more from I'm an individual drone pilot who can fly, the flying skills being less important and being a system operator, knowing how to plan the missions, program the routes, send the data out, send the drone out to collect the data, what to do with the data, how to process it, analyze it, all that stuff. And as beyond visual line of sight rules become available, you're going to be able to cover much broader areas, and that's going to unlock a lot of large scale opportunities for drones, drone inspections, large scale mapping projects. Okay. All right. 2 through 4, $1.2 trillion infrastructure investment. So there was stuff passed. Hey, we need to improve America's infrastructure, and we're dumping tons of money into fixing bridges, roadways, making new roads. And the Department of Transportation, or maybe Highway Safety Administration, put out a report that said, hey, we can achieve 40 to 60% cost reduction with using drones for inspections. So they have money set aside specifically to help make sure drones support that. Again, AI integration. Everybody thinks, oh no, AI is going to like put everyone out of a job. Again, AI, at least in this context, is there to help speed up the processing of the data, or maybe categorizing the data afterwards. This is helping the people who know how to run the system to be more efficient. AI, I don't think is going to put everyone out of a job. I think it's going to put the people out of a job who know how to do everything manually. If you become a system operator versus just a drone operator, and you understand end to end, that's where you can continue to be valuable. And then the last one is just enterprise adoption. Like I've told you this, but there's, this is industry reports. 60% of businesses are already using reality capture, and then 62% plan to spend more on it. I believe that comes from a drone deploy market report. But again, it's the adoption, the amount of people getting into this, like enterprises investing money into this, is definitely
becoming a must for every company. It's becoming a must for engineering firms, survey firms. Like now it's another tool that being used, and industry needs people who know how to operate that.
And one thing you could argue, there's the ban on new DJI specific drones. You can still use DJI drones or buy them, but they're usually FCC's not approving new ones. So this again lends itself to if your whole skill set before was knowing DJI and knowing how to, like, the ease of use of sending that drone up, but you didn't really have the other elements in there of knowing how to do it regardless of the software you're using, regardless of the drone you're using, understanding the actual principles. If you can become that and operate really any drone, because the principles and the methodology is the same from drone to drone, then that, other than the cost of equipment, right, that will be in your favor. We'll see how it shakes out with what equipment is available and out there. Again, you can always go to the drone rental thing, and I would imagine drone jobs would start to kind of have to pay more because no one's gonna be able to do them if DJI drones get totally phased out. But they're still around. Almost everybody I talk to still uses them, unless you're doing working for the federal government specifically. Another interesting stat that I saw, okay? So 427,000 Part 107 holders. This is at least the most recent thing I could find. Almost 500,000 people with a Part 107. So you would think, this market must be saturated. Well, if you look, there's a report that came out that says the industry, so I'm talking about sort of the drone data side of things. They say they can only fill 60% for aerial data, aerial mapping. Only 60% of positions can be filled with qualified candidates. And it's funny, I was having a conversation with someone yesterday, big company, internal drone team. One of their drone pilots made a big goof, right? He flew a drone very close to a very large, expensive piece of equipment. It caused a lot of ripples within the organization. They were getting upset, like, this is too high risk and blah, blah, blah. And so they were thinking about firing him. And I said, well, dude, there's a lot of drone pilots out there. If you let him go, like, is he hard to replace? And he goes, dude, actually, it's very hard to find someone who knows what they're doing with what we do, which is all of this geospatial work, understanding how to do high accuracy mapping and modeling. He's like, a lot of drone pilots, not a lot of people who actually know how to do this stuff specifically. And it seems like that's a pretty broad problem. All right. Flying drones easy, processing and looking at the data is hard. So this was a quote from GeoWeek News. This person, Addison, was like president of the Geospatial Workforce Council or whatever. It says, hey, the need for skilled professional is varied, but overall really strong. Any given day, 20 to 25,000 job openings in the space, and that's forecast to double in the next 5 years. This quote is only like a few months old. So doubling the need for qualified people. They can't fill the positions with qualified people, even though there's a lot of people out there with a license. So the gap isn't, do you have your Part 107 license, is do you know how to do these specific things and have that knowledge? Okay, so hopefully you can improve that here today. So here are the layers. Flying the drone. I would say most of you on this call probably have level 1, right? If you can fly a drone, great. You do need to know how to do that in case you need to take over manually or do something like that. But levels 2 through 5 is where you actually make the money, okay? That is understanding geodesy and coordinate systems, understanding ground control and GNSS positioning, understanding data processing, photogrammetry. I would add LiDAR on here too, okay? Deliverables and client communication. Are you giving them something that they actually need? So Rut will show you some specifics on that. All right, so let's talk about it. Here's the workflow. I want to walk through what it is, and then Rut's going to show you an actual example of going through his real project. So you got PCPAD. I like to break it down into acronyms. All right. So number 1 is plan. What you're going to do is before you go on site, things you need to plan for. You need to obviously safety. So what's out there that I could hit? Are my settings right? Like if I program a drone flight in at 100 feet, but there's cranes on the job site that go up to 200 feet, that's obviously going to be a problem. Am I in the right airspace? Do I have permission to be here? All of those things. So safety. Then there's the actual data requirements. So what is this person actually looking for? My boss sent me out here. What do they need? Do they just need a photo of the building? Cool, that's pretty easy. You fly out there, take a photo. That's pretty low value. Do they need to know if these manhole covers were actually, placed in the right spot? Or do they need to know if the grading of the base layer of what we're doing is flowing in the right direction before we pave to make sure the water runoff is following the engineering plans? That's a lot harder. That's going to require a lot more accuracy. So you're going to plan that differently. Then you're going to actually go out there and design your flight plan based on that. Programming the drone. What do I need to fly? What path? How do I space that out? What overlap do I need? What do the conditions need to be like? The weather, cloudy versus sunny, all those things. All right. Your GCP, your ground control plan. We'll talk about that in a minute. GCP and check shots. How many do I need? Right? How many ground control points do I need? You might not even know what those are. We'll talk about that in a minute. How many check shots do I need to get to make sure this is accurate? Does it need to align to some ASPRS standard, which is like a organization body that regulates, mapping professionals or gives standards there? Does it need to be up to that requirement? Because if so, I need to get 30 check shots. That's a lot of work. So there's a lot of variables to understand how to plan this out and what to do, because the biggest waste of time, drones are really, really valuable, but then you get a huge waste of time when you decide, ooh, I did this wrong. I got to go back out there. I got to maybe do more ground control. I got to go back out there and refly. That's what is frustrating. That's what costs companies money and time. And that's what they want to avoid. That's why they want trained people knowing how to do this. Okay. So Rut, anything else you throw in the planning phase here while we're explaining this?
No, you basically covered everything. Safety is important, the data requirement, flight planning, knowing how many ground control point and check shots you're going to get. I would add one more thing, would be like a QC point. So if you're working with a survey firm, a surveyor, if you're working with a surveyor, you need a lot of quality check. So, they would send out their field, the crew to, let's say, 100 acres, right? They would require 100 check shots to check if it was actually, does it match the accuracy of those check shots collected with the Trimble equipment versus your drone data. So those are one of the things, you would plan beforehand. So for example, to give you an example, if you are surveying a big forest area where there's a lot of vegetation, you would need a lot more QC shots because you would need a lot more QC shot because it's hard to penetrate the vegetation and get the accurate. And I'm talking about you need like this much accuracy, tenth of an inch, like this much accurate, or tenth of a foot of an accuracy. So it's very important. So I would add that.
Yeah, and that kind of comes into play here with like what's your check shot plan, but like what's your accuracy requirements? Yeah. All right. So then the next thing you're going to do is you're going to go out there and capture. This one is usually the simplest. If you've done this planning part right, capturing is usually pretty simple. You go out there, you're launching your drone, and you're making sure that it's capturing the information that you set up in advance. It's usually all automated to make sure you get the exact overlap and the exact areas that you need. Capturing would also, so this would be the actual like drone data. But then this also might be capturing your ground control.
Yes.
So ground control, for those of you who don't know, you would go out and set up targets that the drone can see from the air. And then a surveyor, field crew, or, if you needed to do it, depending on if it needs to be stamped by a surveyor, who's overseeing the workflow, you get a GPS receiver, set it up on top. These things will get very, very accurate coordinates for each of those targets. And once you have those numbered, and once you get those in a spreadsheet, and then after you fly your map, it pieces it all together. And in your map, you can see each one of these targets. And then you're able to tag this target's number 1, this target's number 2, and you tell your system, the software, what are the coordinates of those targets. And I'll show you an example of this in a minute. And that way it can adjust and fit your map to those exact coordinates. So at least at those specific points, those coordinates will match exactly. And if you've done the rest of your process right, you can trust the rest of the map to be exactly in place. And that's where those check shots come in. So you would say, hey, if I click on this point in the map, what does the map think that those coordinates are? And then I can check those against what I actually went out the field with my sort of GPS receiver verified. And it'll show you those differences. And that's called RMSE. That's a little bit more advanced, but we'll talk about that in a minute. Root mean square error. It's just a mathematical term that your software will spit out that says, here is the observed error on how far off your calculations might be, right? So you go capture the data and you would get the information. Then you're going to go process it all. So you get all that data back, your GCP data, your check shot data, your images, maybe your LiDAR data, load it up into some software. So this can be anything from Pix4D to drone deploy. That was a PI. Drone deploy. I mean, there's so many.
Terra.
Propeller. DJI. Terra. Virtual surveyor. On the cheaper end, there is, Pix4D Basic is relatively cheap. If you're just getting started, I would look at Maps Made Easy. And one that's been getting a lot better that I like too is Birdie.
Yeah.
.io. You can also do things like Metashape. That's sometimes maybe more for 3D stuff, but you can use that. What's the other one? They just changed their name. The reality capture one. It's free, but it's a little bit tougher to use.
Reality capture.
Is that what it's called?
Yep. It used to be context capture by Bentley System, but now it's owned by Epic Games.
Yeah.
Reality capture.
So there's a whole bunch of different options, but essentially you're going to put all these photos in. The system does a ton of math. A lot of these are cloud-based. Some are based on your desktop. Software does a ton of math to ortho-rectify the image, basically make everything look straight down and make everything measurable. So it knows the geometry, it knows the distances between things because of how you've done it. And if you're unfamiliar with mapping, drones will fly overhead, take pictures down, right, that overlap like this. This is like the field of view of the photos. And then it finds all these different tie points, like common points in the photos. And each one of these pictures has a GPS stamp on it, a coordinate stamp. So it says, when I took this photo, here's how high I was flying. Here's the exact GPS coordinates I was at. Even as it's flying through the air, it knows exactly where. So that's how it can relatively place all those images in your map. And then it uses those tie points, the common points, to stitch everything together, know where everything's at. So that way you can get a pretty good model. And then it uses your ground control points to get the final like sort of placement on the map. All right. Is it yeah, I think that's what it is. I think it might be reality scan now. Someone said that. There's a bunch of different options, right?
Yeah,
Esri's got some
name,
drone to map. I mean, there's a bunch of different photogrammetry processing options out there. All right, so that's what you're going to do. You're going to process that data. The next thing you're going to do is analyze that data. Okay, now that I have it all here, this would involve, I would say, doing your quality control, quality assurance checks. Is the data accurate? Did it come out right? If I've got big errors in there, I might need to be like, oof, what happened? Do I need to go reshoot some checkpoints? Do I need to go refly? But otherwise, you're going to go do like the calculations you need, depending on what it is. So Rut will walk us through one in a second, but some examples might be, let me just share this with you. So I'm going to show you an example of something called a takeoff calculation. All right. You guys see this? All right. So this is from our course in the Advanced Drone Mapping and Modeling Certificate Program, Advanced Drone Mapping for Construction and Engineering.
There is
data. So this is Nate. He is a survey manager at Kiewit. They're like one of the largest construction and engineering firms in North America, and he handles a lot of their drone program stuff. So he's showing how to do something called a takeoff calculation. So they're going to go out there, there's raw land, and they need to get everything to a different level. So they got to figure out where they need to pull dirt from, where they need to put the dirt in order to get it to the elevations that they need that meets the engineering design plans. So once you have that, then they'll have like a total number. So that way they'll know if it's called a waste job or a job where they need to bring dirt in, because dirt is really expensive and moving dirt is expensive. So they need to budget this and say, we're going to need to purchase 25 truckloads of dirt in order to complete this project. Or maybe they have extra dirt on this job site. Oh, actually, if we smooth everything out and get everything where it needs to be, we're going to have 7 truckloads of extra dirt. Then they can go, oh, we've got this other job site, a few miles away, and they need dirt. So it helps them coordinate among their projects if they need, for their budgeting purposes, and how much work is going to be involved in moving that around. So that's what sort of an example deliverable might look like. And this is sort of the final cut and fill report that would spit out. It would show you in these different quadrants what the cut is, what the fill is, and what sort of the net difference is. So that way when they're planning things out, they can make sure that they're doing this according to the plan and that everything is correct. Because if they don't do this, they can be off by a lot in their cost estimations. So that'd be part of the analysis, depending on what you're trying to do. Maybe Rut's analysis is, getting some type of surface file for a surveyor so they know what the base ground looks like. That would be your analysis. The next thing is delivering that report to the end customer. So Rut oftentimes will have to deliver a report, like a survey report that shows what the topographical information is. It would show it would talk about their process, how they control quality, what their accuracy rates were, all these things to provide assurance to the end user that this was done according to some standards or according to some process. Here are the results. Here's your final deliverables, whether that's different, something called like a DXF file or a TIN surface, which is essentially a collection of points that they can then import to their software to then to be able to start designing off of or to comparing other data that they have. All right. All right. So those are that's the general process. I'm gonna turn it over to Rut real quick and let's talk about one of your projects. So do you want to share your screen, Rut?
Sure. 1 second. Share my screen.
And I see you got questions, guys, and we'll dive into those as much as we can. At the end, we'll have some time for Q&A to ask all this stuff that you got.
Let me know if you can see my screen.
Not yet.
You don't see my screen? I shared it.
Oh, I got to put it up here. My bad. Hold on. It was there. I had to click a button. I'm sorry. Try again.
1 second. All right.
All right.
All right.
So Rut, first, like lay the groundwork. What was this project for? Who hired you for it? And like, what did they need?
Sure. So there's environmental company. I'll give you the info right now. Ecotech Environmental Services, and they hired us for this project. It was a They needed a topographic survey over 146 acres. All this area you see in the yellow for drainage and permitting. So they wanted to do some drainage work on the entire area and some permitting. So they needed a topographic survey for it.
Okay. All right, so you knew that. How did you go about planning out this job? Like, what did you look for in
So
terms of the drone you were going to use and ground control plan, all that?
yeah, I knew as soon as I looked at the site. In most of the time, we don't have to go on the site to look at it exactly how it is, but it looked different, and the level of detail that they wanted. I thought it would be a good idea to just drive by and kind of see what the actually looks like in real life. So we drove by, trying to saw, and I saw there was a lot of vegetation in that area. You can't see from Google Map right here, but all this is vegetation. So I knew I needed a lidar for that, along with because they wanted to get the bare earth model. We decided to go with the lidar along with photogrammetry, and we had a survey crew with us to get a lot of QC shots. So later on, they can verify it independently. So for example, they collected over 198 shots that they did not give us. We mapped, process the data with our ground control points and check shots, and then we give that data to server, and they run independent check on those 198 to see if it matches on each point. And but because the level of detail they wanted for this specific project, so we decided going with lidar. So we flew M300, DJI M300 with L2, Zenmuse L2, that does photogrammetry and lidar at the same time. It has 5 returns. We decided to go with a non-repetitive method because it's good for repetitive method. Lidar repetitive method is good when it comes to be doing like a buildings or parking lots or where there's a lot of structures. But non-repetitive is good for vegetation. But we went ahead and did non-repetitive, repetitive, and combined, processing later on just to have extra data if we need it. But we went ahead with the original plan, which was non-repetitive, and that's how we planned on. Based on this area, my um, on any site, I usually do like 6 GCPs minimal, and because this area has a little bit of extra area, we decided to add another one, seventh. So you can see we decided to have 7 ground control points, kind of planned how we're going to do this. And the white area you see, it's actually the flight plan. So always fly higher or larger the area than what your client gave, because sometime you will need to cut it down, or they may need something, or you may have to see what is going on right here or anything like that. So always fly a little bit extra. So that's how I went about planning the project. So DJI M300 with L2, because I knew we would need LiDAR because of the vegetation, and LiDAR does a great job seeing under the tree canopy, the actual ground, because they needed this for drainage and permitting. So
Cool. So you got your GCPs out there. You work with the field. So, the survey firm you work with has a field crew. And for the rest of you, it's good to understand how shooting the GCPs works, and to be able to do it on your own. But, depending on every company you're working with, they may want their own field crews to do it, or they may give you a ground control point file that you would then utilize inside of your, project processing workflows later.
yeah.
Are you pulling something else up, Root?
Yes. Well, I'm saying, okay, so after we decided what equipment we're going to use, we decided, how much overlap we're going to choose, because it was they needed high accuracy. We decided to fly at 250 feet because we had a lot of batteries. So, why not use and collect more data? They also needed some obliques photo of the property. They just wanted to have it for their own record. So we did that. 250 acres. The overlap we chose was 80%, 80 front and side overlap, because we needed high overlap for this. And it's a little bit overkill, but it's good to have the high overlap. It's always a good thing. The other thing, the minimum requirement was for LiDAR point was 45 points per square meter. We ended up collecting 300 points per square meter, but that was the requirement. So always trying to go above the requirements. And modern LiDAR does a good job of collecting that much data.
And Root, from a photogrammetry perspective, let's say they were like, hey, you know, we don't necessarily care about the bare earth in those areas where there's vegetation. You know, if you're flying at 250 feet with what you had, your GSD, so for those of you who don't know, GSD is ground sample distance. That's sort of the amount of ground space that is taken up by 1 pixel of your, you know, image. What would like your GSD be for that, for the photogrammetry?
So actually, we had a GSD requirement, which was 2 centimeter
Okay.
GSD. So we did that. That's why we flew a lot lower and a higher overlap to get that GSD requirement.
So for those of you who are unfamiliar with GSD, if you think about a picture is just a collection of tiny, tiny colored squares. Each one of those is a pixel. And that's what recreates the model that you're using in photogrammetry. So really you can only measure from pixel to pixel. So when you're trying to figure out what your accuracy is and how much you can claim in accuracy, you're never going to be able to be more accurate than for measuring from one end of a pixel to another end of a pixel. So if each pixel in the image is, let's say, 2 centimeters, your total horizontal accuracy is probably going to be 4 centimeters is what you would say. So like, because you know, if you've got 2 little squares, you might be on the edge of each square of your pixel if you're really zooming in. So that's covered in our fundamentals course, but I wanted to explain that here in case you were curious how that relates to accuracy. All right, cool. So you got all that in place. You got your ground control. We know the requirements. You did your data capture. I'm assuming you don't necessarily have any like documentation of the data capture other than the final images and LiDAR stuff that it got.
Yeah,
how
I
long
can
of a
show
flight was that?
what it looked like.
Yeah, pull that up. How
You
long
said
of a flight
how long it?
Yeah, like
It
with
was
the data
about,
capture part.
well, the total time on site with the drone in the air was for 2 hours because we had to capture the.
Like multiple passes
We
for
did
different
2
things.
flights essentially. We did two flights because we needed to do one repetitive and one non-repetitive.
All right. So is this the resulting model?
Yeah, I'll get to it, but let me show. I created a demo project folder for it. Okay.
Yeah, wait, so you got it up.
Raw imagery. Okay, so photogrammetry, this is what the data look like.
Just a bunch of pictures.
Bunch of photos, thousands of photos. And then we had some oblique photos we needed for the property. So it was a huge property, and you can see there was a lot of vegetation like this.
Mm-hmm.
It's not a lot compared to the area behind it, but there was still a lot. Here is a video I think you all will enjoy. This is another, I captured this M300 flying with LiDAR with another drone, kind of air-to-air mission. So
That's cool. Cool shots.
So kind of get the idea of the property and the data capture.
Yeah.
So this what the data look like. And after that, we came back, verified data is good. And then I went to DJI Terra because you can use any other software, you know, like Pix4D or anything like that. But because we had LiDAR that we used, since we use DJI LiDAR, we had to use DJI Terra to convert raw files into LAS file to process later. So we use this, but you could use Pix4D. If you're doing photogrammetry, you can use Pix4D, virtual server, anything like that. So
yeah. So this is what your
DJI Terra. Yeah, this is a LiDAR model, but this photogrammetry, we process it separately. It has its own reason why we did that. There is one thing in DJI Terra that you cannot, well, you can attach GCPs to your photogrammetry model, but you cannot do that in LiDAR. I think they're going to release that in the update. So we did that in other software, TerraScan from another company. But anyways, this is a photogrammetry model, which is GCP aligned. So you can see all the, this is, yeah, this was the type point that David was talking about earlier. This was the photo on the left. You can see the photos it was taken and what that photo see right here. And here, all the GCP location, all the 7 of them. So
zoom into one of the GCPs so we can see it from the sky. Yeah, there you go. So you
So
tag the
this
center of that so your software knows where that is, and it matches it up with
yeah,
that exact GPS point that you have, those coordinates.
exactly. It matches up with that. First, we
Cool.
had to select the coordinate system. We selected this 6443, which is Florida West 2011 NAD 83. So we
And let me
use that
stop you real quick,
coordinate
Root.
system.
This kind of stuff, the coordinate systems and understanding this with geodesy, geoids, all that, that is the kind of information that most drone pilots don't know, that usually surveyors do know, maybe some engineers know. That's sort of one of those separators. Like if you understand coordinate systems, reference frames, datums, what you need to use, how it integrates with the project, how that affects what you're doing, that's one of the biggest complaints I've heard from big companies hiring drone pilots is they're like, yeah, they get out there, they think they know what they're doing, but they really don't understand any geodesy or coordinate system stuff. And then they give us data that's in the wrong format. So when we load it into our systems, the project shows up like somewhere else or off by a foot or on the other side of
And
the
it's
street,
unusable,
and it's
completely
unusable.
unusable. It's
So if you
waste
make
time.
yeah, so if you make those mistakes, you don't understand that stuff. You don't understand the GCPs and how to do the check shots. Like that is the separating fact. That's why there's only a 60% fill rate because another
Exactly.
40% they don't understand how to do this stuff. You know, so
And it is the what separates from just a drone pilot or someone who know what they're doing and you knowing what kind of GCP to use. So for example, let's see, this was all vegetated area, so we use this kind of GCP, right? You can see right here. But because this was a road, we decided to just put a white tape on the
sure.
on the ground to kind of see.
Yeah, cool. All right, so let's take a look at what the so we can keep going. What kind of the final deliverable? Do you have what that looked like for them?
Yeah. Well, after we did the photogrammetry, we did the lidar. As you can see, we did mapped many of them. But this is what the lidar looked like, and you can see it's a 3D model. We wanted to know exactly what the ground looks like underneath this tree. So we can turn off the point not classified. It just shows ground. But if you can see, DJI Terra does a great job of filtering the ground. So you can see there's still some grass and stuff like that, which is not good, which is not usable. So we went ahead and went to Terra Scan and Terra Model to do a lot further process. And now this is super advanced level processing where you have to, kind of find the bare earth and connect it to the GCP, what it looked like, stuff like that. So we did in here, and then we came to Virtual Surveyor to kind of create the contour maps and stuff like that for this. Um, just show something real quick. And then we had to create a grid point. So there is 10-foot grid point. So every 10 foot, there is one point on the ground that shows what's the GPS location for that, what's the northing, easting, and elevation of each point. So surveyors can use all these points to create a big surface that they can use there in their survey and topo. I'm going to show the final product too, but I'm kind of showing the steps.
Yeah.
What kind of stuff are involved in this stuff like this? So,
Well,
I'm
this
sorry.
is
I
was
said
gonna
10
give
foot. It's a 3 foot.
yeah, I was gonna say it looked. So just to give you some context, if you had a project, you would need this information first before they would then go in and let's say they would design what the earth needs to look like. This is what they're going to use, those surfaces of what the bare ground is, and then they can compare that to where all the earth needs to be, and that's how they're going to get those
Yes.
cut fill maps and those, it's called takeoff calculations of how much dirt they need to move where. They can do all their other planning too. This is like the basis of where they build the engineering plans off of to build whatever they're going to build. All right, sorry, keep going, Rick.
No, that's good.
Okay.
After that, we kind of do like a GCP checkpoint check shot. So like we saw the GCP, we can see the RMSE was 0.12, which is okay. Before we did any of that, and but based on this was a huge area, this was acceptable for the server. So we proceeded with that, and then they gave us all the check shots. So we separated those check shots. So TG here you can see TG. TG stands for tall grass. So if I turn that on, you can see all in the tall grass, their check shots, right? So you can do check points, and you can see it was 0.21, which was acceptable for this project. Short grass was 0.12, which was good. You can see right here, short grass that they just survey crew collected. And again, they collected this. I didn't use this data to process my data. I just used this point to verify how good my map is. So stuff like that, we did that. And the final deliverables were like this. Let me show you.
Here, I'll pull your screen off so that way you don't record any of your other sensitive information as you navigate around.
Oh, it's okay.
You ready?
So this was the deliverable data. So first we give them a 10-foot grid, which was looks in a CSV format. This is what it looks like. So P is the point, X is northing, Y is easting, and Z is for elevation. And D is the description, which says the grid points. So P, X, Y, Z, we were able to create this that shows
how many rows is that?
97,109. So a lot of points we were able to.
It's kind of funny to be like, oh, after all that, you just get a spreadsheet of data. But really, when you take that spreadsheet and you load it into, any of
I'll show what that data looked like.
Yeah, when you load it into a CAD program, it can recreate what the surface of the ground looks like in that area based off. That's like the raw information data.
I'll actually show that. I'll pull that data so they can see what this final product looks like on the client's end. We give them DSM, so digital surface model. So let's see. Let me open a global mapper. I had it open, but I accidentally closed that.
All right, I can look through some. If you guys have questions, feel free to throw. I know some of this might seem over your head. Real quick, this is the advanced training that we're doing. Next week, I'm going to do one for if you're like brand new to photogrammetry and mapping. I'll bring it down to a really basic level. But this is, again, sort of what the advanced applications of mapping and modeling look like.
So this is a digital surface model. That's what it looked like that we give it to the client after all the filtering. So that was one of the other thing. All right, let me move on to LAS file. So classified and just the ground. So for example, this is the whole LAS file. LAS files is for like a point cloud. So laser point clouds, LiDAR data basically. So let's see. All right, I'm going to draw a vertical section so you kind of see right here. You can see what the data looks like. And if I just turn off all the other data and keep only the ground, you can see. This is what the ground. So finally, we give them this kind of data too. So classified, that includes everything, and ground, that just shows only the ground. And orthomosaic, let me see if I can pull up in here. All right, so here's the orthomosaic, the photogrammetry. So they can get the idea of the entire site, what their site looks like in one photo.
Yeah, love it. All right. Well, hey, I know it's getting late. We've been talking for an hour. I was going to tell you, for those of you who are interested in diving more into this, let me show you some stuff. So I told you.
Well,
for those,
let me show the final
report. Oh yeah, go ahead. Is this the final report?
The final report that shows what we give them. What was the thing? What was the accuracy, vertical accuracy, all the check shots that we collected. So there was like 6 points in that: bare earth, short grass, tall grass, 123, 198 total. What was their RMSC on each point? Stuff like that. And it was signed and sealed by the surveyor.
Awesome. Love it. All right. So that was like a really quick crash course end to end of everything that you need to, that Rut knows how to do here. Okay. This is like a land surveying deliverable, but there are other types of deliverables that you could use in civil engineering and construction, different deliverables maybe for 3D modeling and inspections. Like if you're doing a bridge inspection, that's a little bit different. So uses the same core principles and process of ground control, verifying your accuracy, capturing data, but what you end up using it for can be a little bit different depending on what you're trying to get. All right. So I know we've talked about a lot. Not everybody is interested in like going really deep with this, but if you are someone who's like, I want to have a job in this, or I really want to take my business in this direction, and I need to understand this stuff in depth, we spent a very long time finding the best people possible to teach this stuff. We got everybody who are actual practitioners that do this every single day. And so we created an advanced drone mapping and modeling certificate program. It consists of 5 courses. You get these, you take exams after you finish the courses to get these certificates. There's 5 courses. If you finish all 5, you get this, nice little badge here plus a certificate that you can validate on an external website. So this is for people who are like, I need to show an employer or I need to show a client that at least there's some third party that has validated that I know how to do this. And I'll show you an example later. Someone was trying to get a job with a utility doing geospatial work, and they asked Gemini, hey, what training programs can I do to show that I know how to do this work? And it actually recommended our courses, and he signed up for them. So I thought that was pretty cool. So the courses are, I'm gonna go through these real quick here. So number 1, geodesy for drone surveying. This is that foundation, coordinate systems, datums, reference frames. This is, I'll show you the teacher in a second. Next one, GNSS positioning and survey control. How to go set those ground control points. Everything about RTK versus PPK. We didn't even get into that today, but it's different ways of validating or making more accurate those drone images that we're taking. How to test your accuracy, improve that, like on that final report that Rut gave. Here's the accuracy we have. Here's how we know. Advanced drone mapping for construction and engineering. That's that course I showed you where we did all the takeoff calculations. This is working with engineering plans and design plans for when you are doing civil engineering work mostly or other construction work. Next is advanced drone mapping for land survey. That's what Rut teaches. So he talks about how to get these outputs, walks through this whole thing, how to do planimetrics, contour maps, stuff that surveyors look for. And finally, advanced 3D modeling and digital twins. That is for facades, that's for vertical structures. So think bridge inspections, anything in 3D space to be able to do that and validate that. All right, so the instructors I'll go through quickly. Geodesy, the first course, taught by Dave Doyle. He used to be the chief geodetic surveyor at NGS. He literally helped create a lot of these reference frames and geoids and all that stuff that are taught, that people rely on. He's probably the highest level expert in the United States for this stuff. And I couldn't believe that he said yes to creating this course. So he is the #1 main dude, right? So he teaches this stuff. He's the one who teaches that course. Next one is Chris Breedlove. He's a geomatics expert right now at, he doesn't work for Withers, Ravenel. He used to sell geospatial equipment like all these GPS receivers and would train companies on how to use them. So he talks about how to get ground control. Construction and engineering, taught by Nate Howard. He's a survey manager there, one of the main leads on their drone program. I think right now he's responsible for half of North America in terms of their survey work and all their drones. They deploy hundreds, if not thousands of drones across their companies. They use it on hundreds of projects. Extremely talented and smart guy. Rut, you already know him. He teaches the land survey course. Ted Strazimiri, probably the most highly respected 3D modeling, reality capture, digital twin guy out there. He gets invited to go speak at international conferences on reality capture. He's consulted with, I'm pretty sure, every single major drone manufacturer. When I went to film this course, he got calls from, I don't know if it's public who he's working for, but like calls from many different drone manufacturers that you have heard of. And he's on the phone with them, troubleshooting their stuff and talking about testing their gear out on these projects while we were in the middle of filming and stuff. So super, probably the most intelligent person I've ever met in my life when it comes to 3D geospatial stuff. All right. These courses actually also count for surveyor and engineering license PDH, so professional development hours. So if you are a surveyor and an engineer, if you watch all the videos, you read these, each of these come with their own textbook, go through all that, answer all the questions, do all the tests. You can actually get over 40 hours of professional development hours. That's over 2 years worth of your professional development time that can be satisfied by these courses. And again, these are the advanced ones. These are really high, very specific courses. So if you're wondering, David, this sounds like a lot. How much are these things? Well, obviously the answer is they are probably expensive. If you're just like a newbie and you're kind of on the fence, this is not going to be for you. But if you're like I'm a professional, I want to be a professional in this, I want to dedicate myself to this and really go all in and learn this. This is probably the only program that I think exists out there outside of going to get a 4-year degree in geomatics. And I'm not saying this will replace a 4-year degree in geomatics. If you want to do that and be a licensed surveyor one day, please go that route. But if you're trying to learn how do I create opportunities for myself in the drones and data world and geospatial, maybe I can go get a job as a drone operator at a DOT. My friend who I told you about earlier, he was making 6 figures. He doesn't have a geomatics degree. He's on their virtual reality or their reality capture team, right? And so he had to get trained up on this stuff. Actually, that same company ended up using these courses to train their internal drone teams. So it's expensive. So the full price for each one of these courses is $399 for the first 2, and then $799 for the more specialized ones. So if you were to buy these individually at full price, it would be $31.95. Okay, really about the price of like one advanced degree college course, maybe 2. Because I used to take some drone UAS classes at Embry-Riddle, and I paid about $2 to $3 grand per class. So you get all these classes and all of your PDH for that. Obviously, we always run discounts for people who are on these webinars. So if you want to do this and you want this whole bundle of all these courses, we're giving $1,200 off. So that's almost 40% off. So you can get all of these for $19.95 if you want to jump in. Real quick, I just want to show you. These are people who have gone through and gotten these certifications. You can click a button, they get posted to LinkedIn. People have really, really enjoyed them. I looked right before this. We've issued 173 advanced drone mapping credentials in the last 12 months. So people getting in there, learning this, posting it. This was a guy, Nick, I just emailed him. This was the one I was telling you about, where he signed up for these courses to go get his training, to go, get a job doing this. He just said, hey, I've really enjoyed them. Thanks for putting it together. I thought that was nice. All right. So if you want to do this, the link, you can do so Advanced Drone Mapping and Modeling deal.com. If you do that, it will take you to the checkout link with this already applied. If the code is not applied, the code is ST 2026. That stands for sweet tea, since that's what I'm drinking right here. Sweet tea 2026. Again, if you're just starting off or you're not really like wanting to dive into this education, get certifications, no hard feelings. I know that is not going to be for everyone, but I know there are people out there who want to make a career out of this or take their business in this direction. And I think this would be a really good asset for you. If you learn how to do this and you land literally one mapping job, that's even at the lower end of what people can charge for mapping jobs, the course has already paid for itself. Now, I know you're going to have to go maybe rent some equipment or whatever, but you should break even in one job, maybe 2. All right. And if you want to go get a full-time employment, like I said, drone pilots who know this versus who don't know this, they make 30 to 60% more. So it's like 20 to 40 grand extra per year. So if you can get a job doing this versus something else, again, this should pay yourself back in 1 year. I invest a lot in myself in courses and education. So I'm personally biased to thinking the more you educate yourself, the more you can earn in your career, right? So there is also an option. Here we have some Q&A. There's also an option for those if you want to split it up over 4 months. We offered an option for I think it was $550 per month for 4 months. If you want to make it more palatable that way. Okay. So if that's an option you want to do, split it up, you're welcome to do that. It comes out to a little bit more since you're spreading it out, but it might make it easier for you. Audrey, how do they get the $550 price? Audrey's in here. She's helping me set this stuff up. Oh, yeah. While she's answering that, I was going to tell you a bonus for people who buy by the end of today. So this deal should be good until Friday at midnight. Okay. At midnight. Oh. At midnight this week. Okay. You have lifetime access to the course. You have 30 days to go through it. If you get in there and you decide you don't like it, I'll give you a full refund. If you get in there and you're like, actually, this is not what I need, or this course actually sucks, David made it sound good, but it's not, 30 days, we'll give you a refund right there, okay? And then the last thing was bonus. So for everyone who gets this by midnight tonight, what I'm going to do is when we first launched these courses, all of these instructors taught it live over Zoom. They each did like a 1 to 2 hour session on Zoom. And what they taught in those live classes was not the exact same stuff that they taught in the final recorded sessions where I went on site with them and did projects. They shared a lot of additional extra information, had Q&A from people. So those aren't released to anybody. The only people who have those are the ones who signed up for the initial beta launch of this like a year or a year and a half ago. So for everyone who signs up tonight, I will also give you all of the live recordings from all 5 of those instructors from our original sessions together. So you can have all of these certification courses. But if you want to dive deeper, there's a bunch of stuff in there that you will learn as well that is not in the normal one. Okay. So that's the extra bonus for people who sign up tonight if you want to do this. All right. I don't know if Audrey is able to post that. So we'll send out an email too. So if you go here, it'll take you to the one-time purchase, and that'll get you in. But if you want to do the 550 deal, we'll send out a link for that as well. Okay. All right. If you do have any questions, feel free to email me, David at Drone Launch Academy. Long name. I don't know why I picked this name 10 years ago. Academy.com. And we'll get you sorted out. So if you need a link or something else, let me know. I can get you sorted out there too. All right, we got about 15 minutes for Q&A. Before we go, or Root, do you have 15 minutes to stick around and answer questions?
Yes.
Oh, somebody asked, what if I'm just starting off? Okay, if you go to this link here and you do purchase, or you go to purchase, you should see on that page the option to add on our drone mapping and modeling fundamentals course and our drone map or our Part 107 course. You can add either one of those on for half price. So our drone mapping and modeling fundamentals course will take you from literally zero to understanding how to do photogrammetry at a basic level, and it is what you need to know before doing the advanced stuff. So that you can add that on for like $200 on top of this. And if you need a Part 107, our Part 107 prep course has been used by like 35,000 people. It's really solid. You can add that for $99. So if you're like, I'm starting from scratch, but I still want to get all this just to get the deal, you're welcome to do that and add the fundamentals course on to do this from the very beginning. So there's an option there. I should have said that. All right. I'll say fundamentals course add-on. All right. Questions. Someone's asking about rolling shutter. Talk about rolling shutter camera drones. Had a flight plan with a rolling shutter. In my experience, the higher up you are, the less rolling shutter is an impact because the ground isn't passing by quite as quickly speed-wise. If you are going to fly lower to the ground, the slower you need to go, no matter if it's mechanical or electronic or rolling shutter. And to make sure that you don't have any motion blur with rolling shutter, you would usually just slow your speed down a bit with the drone, depending on the model. All that said, I talked to Ted Strazimiri about this, and he said the algorithms in a lot of these processing softwares has gotten so good that he's never really been able to tell a difference between mechanical and rolling shutter in the data that he's processed, because it's able to parse that out pretty good and compensate for it. But if you want to make sure your quality is good, I would slow the drone down a bit. It'll take more batteries, longer flight time. That's an option. Or fly higher if you don't need as much detail in the image. Hope that makes sense. Here's a question, sorry. Courses taught, videos, books, in person. Okay, so they are all online courses. You have lifetime access. You can go at your own rate. There is a workbook / textbook with each course. For every video, there's a text component that you can have an actual like PDF workbook. They're anywhere, I think, between 100 and 200 pages long per workbook. So these are pretty in-depth courses that you will have with that. You have mini quizzes after every lesson, and you have a final exam at the end that you have to pass with an 80% or higher to get your certification. Once you get the certificate, it goes to a third-party site called certifier.io. We have our own page of that. where anybody can go and click and validate that you have a valid credential that was certified by us as like a third party. Okay. What are the paid software requirements and PC specs? So let's see. This can vary pretty widely. You can go on the free end and go web ODM or on your machine for free, or you can do reality scan on your machine for free. Those come with a little bit more technical setup, and you got to be maybe a bit more savvy. From a basic paid perspective, Pix4D Cloud is pretty solid, and I want to say that starts around maybe like $70 a month. But if you want to start doing GCPs, it's probably more around like $200 a month. Virtual Surveyor has a lot of these have free trials. Virtual Surveyor runs on your machine. That's got a free trial, and I think it's what's Virtual Surveyor costing right now, Root?
It's about 200. It starts with 200 per month and goes up to like
they can all get pretty
315, something around that. I have a Virtual Surveyor along with the other, but yeah, I think the one I pay for is 285.
Let's see. So, pricing. Yeah, so it's like $150 a month for Virtual Surveyor. That processes on your machine. There's a whole bunch, but it's to get something where you're doing like ground control points and good photogrammetry and all that stuff. You're probably going to pay at least $150 to $200 a month. But there are other softwares you can start with, like Maps Made Easy or Birdie. That might be a bit more cost effective up front, especially if you're just learning. But once you're getting paying jobs, you would need those nice pieces of software. That's why those jobs pay a lot more, because you need a lot of times some better and better equipment, and you need more powerful software. PC processing, usually if you go to like Virtual Surveyor, or if you go to Pix4D Mapper and click on like PC specs, it'll tell you. But typically they say you need a desktop computer that will cost you probably at least $1,200 or more if you want to do local processing. But a lot of these cloud-based ones, you don't really need a big specs because it does it in the cloud. Okay. One thing I'm curious, I haven't announced this anywhere yet. I've only been talking to Audrey and Root about this. So you have school we can attend. So one thing we're considering adding on, I'll probably send out some more information about this later this month. We get a lot of demand or people asking about in-person training. So what we're considering doing is, for people who have taken our fundamentals course and they've completed the mapping courses, so they have the head knowledge and they understand what's going on, doing like an in-person, almost capstone training. That's a 3-day in-person training where we're going to go do real projects with Root's nice drones and equipment, and actually do everything hands-on, start to finish, full job through the deliverables. So you can actually touch and feel and be the one clicking around with us with an in-person stuff. That would probably be limited to like a 10 to 12 person group. We'd probably do the first one here around the Tampa area. So I would be curious, leave in the comments, would you be interested in doing something like that? Would you like travel to Florida if you're not here and want to do the hands-on thing after you've finished the online trainings? Let me know. We're going to be sending out like a feeler about that later. But an Air 3S. So for people wondering about compatibility and good starts and all that, if I were you, I would go to dronelink.com and I would look at their compatible drone list, because you can use a lot of cheaper drones with DroneLink. I think the best starter one is an Air 2S, if you can find them used. If you can't, I think the next budget-friendly option is a Mini 3 with the DroneLink software. And DroneLink, if you're just doing it for practice and stuff, it's like, I don't know, $50 one-time fee. They have some other commercial plans too. But a Mini 3 is going to run you $450. You do have to have an Android device to run DroneLink, but I think you can get like a Samsung A5 for maybe another $150. So all in, you're looking at like $600 for equipment on that. And that's probably your baseline tool to start into the drone mapping world. And then if you got really serious about jobs, you might want to upgrade to like a Matrice 4 Enterprise or something, but that's like a $7,000 drone. So I would only do that once you've gotten some paying jobs and you're willing to invest and upgrade and things like that. How many programs did you use to get the deliverable on Root sample project? Well, he was doing more like LiDAR stuff, and a lot of different things, but the typical workflow is, you can use one program, usually use Google Earth Pro to do your planning. That's free. You would use whatever your flight automation software is to do the capture. So if you're using Drone Deploy to process, they have their own flight tools, but otherwise you'd be using Drone Link. Then you would need to process the data. So if you're doing something, so you might be able to keep it all inside of something like Pix40 Cloud Advanced or Drone Deploy or Propeller, and that would be your full software that you would need for the whole thing. For what he was doing, he had to pull it into a couple different pieces of software for his steps.
I had many because the deliverables they wanted. So
Yeah, but typically you're going to use maybe 3 pieces of software. Like in our courses,
Three
all
to
these
four,
courses,
yeah.
these different software, because we're not trying to be like a software specific training company. So in those courses, we show you Virtual Surveyor, we show you Propeller, we show you DJI Terra, we show you Trimble Business Center, we show you Drone Link, like we should use a Wingtra flight application. So you get exposure to a lot of use Metashape. So a lot of different software applications, and you can see that most of them operate in a similar way. The buttons might just be in different spots, but the core functionality, they might do certain things better, but really you can use a lot of different tools to kind of get the same outputs. Yes, there are definitely companies that will process the data for you. You can contract it out. Only problem is, what's that?
We do it.
Yeah. So you can do that as long as you are able to validate the accuracy. So if you have the check shots and the ground control, and you can take whatever output they bring back to you, and you can check that and validate it, that would be good. Will this presentation be available? Yeah, we'll send out the industry outlook stuff to our full email list here afterwards, but this should stay up on YouTube Live at least for a little bit if you want to come back and watch later. We are around the Tampa area. I think these are people who are saying they would be interested in maybe coming to an in-person thing. Okay, cool. Love to travel. Okay, definitely. Maybe a few months. Yeah, we wouldn't do this right now. I'm thinking maybe like a April or May training if we did for the first one. So, okay. Web ODM. Yeah, I just don't ever see web ODM being used much in real enterprise settings. I got to be honest, I don't have a ton of hands-on time with it. I think sometimes the setup can be a bit technical. I also don't think they allow you the option to manually adjust your tie points or GCPs, which can be a limitation for some people. But I have heard of a few people using it for commercial work. So we do not no longer offer new purchases of the Aerial Roof Inspection Pro course. It was a little bit hard to maintain, and also it had gotten a little bit older. We made that one probably like 6 years ago, and I didn't have a plan to do a refresh on it, so I didn't really feel good about selling, that to people if it was kind of aging out. I think it had kind of run its life cycle, so I didn't want to actively promote that. Let's see. Samsung is sandboxing and blocking DJI and other software. Yeah, so the thing is, if you're going to use a Samsung device, it's actually running Drone Link. Drone Link is an American company. You actually can't even have the DJI app installed on the Samsung device in order to get Drone Link to work correctly. But Drone Link has built-in SDK compatibility and connection with certain DJI drones. So if you go on Drone Link's website, you should be able to click through, see their supported drones, and find the information there. So it does work. I mean, I had employees that did it last week. Any thoughts on RTK base station, DJI RTK3, say, versus MLID Reach RS3? And those MLID Reach are getting really, really good and better, even from surveyors.
Like
they've been saying
I
like
use DJI, but I like MLID.
Yeah, I got one right here. So like, for those of you who are wondering what a GPS receiver looks like, so this is the MLID RS3. You can put this on a pole basically and set it down and turn it on, and a little bit too much to go into here, but if you had it connected to an RTK correction source, it would give you like pretty accurate readings. Or you could set it on a base station or set it on a pole and let it run and log something called static data. It would capture all the satellite information once every second and log it, and you could do that for hours. You end up with this giant download spreadsheet of information, and you send that off to a service to the government called Opus. It will look at
Opus.
all that satellite observation data, and it will say, based on all that and all we know about the errors and where the satellites were and all these different mathematical things, here is the exact point of where you were. And then you can say, okay, here's that exact point, and that allows you to have use that as a base station to then, once you get that known point, then later you can put something there and use that as sort of an RTK broadcast system. The methods are explained in the course, but that's what those receivers look like, and they're getting very good. Do any of your projects require thermal? No, thermal is usually only used in commercial roof inspections or building envelope inspections from a data standpoint. So that's usually to detect moisture and water penetration, or solar panel inspections. So you would use the same techniques of photogrammetry for that, but the outputs are just in radiometric. Propeller, it's good software. That's actually the software that we use inside of the advanced construction and engineering course. So Nate Howard, their company uses Propeller. So that sort of takeoff calculation example that I showed you, that was in Propeller. Mavic 4 Pro, not really out of the box. It can't do it. I know some people can sort of jimmy it to create waypoints and then take it and then load it. There's some workarounds, I think, but there's not really a smooth way to do it. Mavic 4 Pro is more of a cinematography based drone. We do have a referral program. If you have an audience of folks that you would like to recommend, you can email me. My email's up there, and we can talk about that. So Mini 5 Pro and Mavic 4, again, the same thing. I think you can kind of get around it with maybe trying to do a waypoint mission and basically saying, take a photo every 2 seconds and fly along this path. You might be able to get away with it, but you don't really get to program it in the way that you should if you're doing it for real. If I were you, I would just get a Mini 3 or a Mini 4 Pro. Those will both work with DroneLink and use that. Those would be cheaper unless you already have those. But those are good for cinematography and stuff. Yeah, I know they allow GCPs. I remember my friend, he was having problem with some reconstruction in WebODM, and he couldn't manually adjust where the GCPs were being detected. How many RTK units do you need on average? Typically, you need one base station and then one rover. So the RTK unit that's attached to that rover. So you should need no more than 2 max. I have another receiver over there. They stay for Opus shots at 15 minutes of receiver data, just as good as 3 hours. Interesting. Yeah. It depends. I know some old school people are saying, oh, you got to let it sit there and cook for a lot longer. But yeah, there's different research that says different things. Cool. Let's see. Yeah, Mini 3 Pro. That's what I like. For getting started, that's what I tell you. If you don't have an Air 2S, I'd go Mini 3 Pro. First drone, I understand Potensic and Skyrim are better waypoints than DJI. Ooh. I gotta be honest, I don't have experience with Potensic or Skyrover. But if you just go to DroneLink,
heard that name before.
If you go to DroneLink's website, the first big button up there is supported drones. You click that and you can see their whole thing. I use Waypoint Map for flight planning. Works very well with Air 3S. Okay, cool, nice. You'll have to check that out. I don't have an Air 3S or Mavic 4, but I do know that some people do that. It's just that you can't control your overlap settings as precisely. And so if you're trying to get if you have requirements like Rut's client, we need this GSD and we need this and that, you might not be able to guarantee that exactly. But again, you could probably work around it. And I'm always a fan of working with what you got. Okay. All right, guys, we're at 2:30, been 90 minutes. I really appreciate everybody coming out to this and sticking around. Great crowd, A+. Thank you so much. So this deal, again, will be good till Friday. Try it for 30 days. Get your certification. We'll have some emails going out. And if you do jump in by midnight tonight, we'll give you all of the live recordings we had from when we first taught this a year ago from all of these people, okay? All right, signing off. Feel free to email me with any questions. Thanks, everybody. Everybody thank Rut for coming out. He's at work right now at his survey firm and took time out of his day to do this for you all out of the goodness of his own heart. So he loves this stuff, and I think he wants to see everybody else succeed. So I appreciate him being here. All right. Thanks all. Fly safe.